class, so this podcast has to do with half-lives. And half-lives is not just a video game, but half-lives refer to things that are radioactive. And a half-life is the amount of time it takes for half of that radioactive material to decay. So if we started with a 500-gram sample of uranium, and we wanted to know how long it took for that 500-gram sample to go to 250 grams. Right? So half of that sample decays, and that's going to take a certain amount of time. And if we know that, we can kind of calculate stuff. It's how radiocarbon dating works, and really past that, it kind of gets a little bit iffy just because we haven't been around long enough to know if huge amounts of time really take uranium to decay or certain things that take a long time. So again, half-lives is the amount of time it takes for a radioactive substance for half of that substance to decay. Alright? So the main application is solving problems, so a little bit of math. And the thing you want to do is determine how many half-lives occur. And that's the first step you're going to do for all these problems. So if we look at this first one, after 42 days, a 2-gram sample of phosphorus-32 contains only 0.25 grams of isotope. What is the half-life of phosphorus-32? So again, our first thing that we want to solve or determine is how many half-lives occurred. So if we start with a 2-gram sample, after one half-life, how much do we have left? We have 1 gram left. Right? If another half-life occurs, how much do we have left? We have half of 1, so we have 0.5 grams left. Right, and if another half-life happens, how much do we have left? We have 0.25 grams. And what's the problem tell us? It tells us we have 0.25 grams. So notice we're starting with 2 grams and going to 0.25 grams. And we want to know how many half-lives occurred. So if we look at our arrows, we had 1 half-life, 2 half-lives, 3 half-lives. So the question then asks, what is the half-life of phosphorus-32? Well, we know that 3 half-lives occurred, and how long did this take? Well, if we look back at this question, it says after 42 days. So we know 42 days happened, and we want to know how long is a half-life. Well, 42 days is 3 half-lives. So if we take 42 divided by 3, we get 14, and that's 14 days per half-life. So how long is one half-life? It is 14 days. Alright? So again, the first thing we're going to do is determine how many half-lives occurred. So if we look at question number 2, it says sodium-24 has a half-life of 15 hours. So now we know the half-life. And it says how much sodium-24 will remain in an 18-gram sample after 60 hours. Okay? So this time it's a little bit different. We know 60 hours elapse, and we know each half-life takes 15 hours. So we're simply going to take 60 hours and divide that by 1 half-life is 15 hours. So in 60 hours, 4 half-lives occur. Alright? And notice this one is talking about what mass will remain. Our first example is asking what's the length of a half-life. So the questions are kind of asking the exact reverse thing. So this one we're going to start with division and find out that 4 half-lives happened. So now we want to find out how much mass is left. So if we start with 18 grams, we want to half this 4 times. So after one half-life, we're going to have 9 grams left. After another half-life, we're going to have 4.5 grams left. After another half-life, we're going to have 2.25 grams left. And then after one more half-life, we're going to have 1.125 grams left. So notice we have 1 half-life, 2 half-life, 3 half-life, and 4 half-lives, because if we go back to the beginning, 1 half-life is 15 hours, 60 hours pass, so we have 4 half-lives. So our final answer is we would have 1.125 grams left after 4 half-lives. Right, our last example, the half-life of protactinium-234 is 6.74 hours. What percentage of a given sample will remain after 27 hours? So now we're not necessarily concerned about mass, but we just want a percentage number. Alright, so again, we know that 27 hours elapse. We also know that 1 half-life is 6.75 hours. And if we do this math, we're going to find that 27 divided by this is 4 half-lives again. So now, percentages, we know we start with a whole, so we start with 100%. And after one half-life, we have 50% left. And after another half-life, we're going to have 25% left. And after another half-life, we're going to have 12.5% left. And after yet another half-life, we're going to have 6.25% left. And again, we might count our half-lives up. That was one half-life, there's 2, there's 3, there's 4. So after 4 half-lives, we have 6.25% left of what we began with. Alright, so again, half-life problems, the main thing is determine how many half-lives happen, and then depending on what the question's asking, we might be using that number to divide, or we might be taking half of something so many times. But that is half-life, and that's our lesson.